Hi again. So in science, we're going to measure lots of things. And in science, how you measure is a very sort of precise skill. First of all, if I want to measure the length of something, which is something I can measure, other things you can measure are temperature or volume of a fluid. To measure length, you use a ruler. To measure a force, you might use a spring scale. There's all these different devices, but there is something common in all the devices, and that is how the little lines are drawn on the devices. You may have been told that the scientists do not use the American system of units, like this side of the ruler has. That's pretty true, but American engineers still do sometimes. And in this class, the reason we're not going to use inches, like this side of the ruler here, is not because we don't like inches. It's because the ruler is broken up in a way that we don't want. So if you have 5 right there, and that would make these quarters, and then you have eighths, and this is called a fractional ruler. And the problem with a fractional ruler is, if you want to measure the length of something, let's say, so you have to line up one end, and you look at the other, and you say, okay, it's a little bit past 3.5, but it's not quite to, what is that next one, 3 1/16. So what do you write when it doesn't land on the line? Now in carpentry, if you're off by a 1/16 of an inch, who cares? In science or in engineering, that's a large error in your measurement, and that would not be okay. So it's not so much that we don't like American units, it's that we don't like fractional rulers. So what we're going to use in our school and in all science and engineering is a decimal scale. So here's one, and if I want to measure the length of that block, I would say, well, look, it's just below 9. Okay, assuming I have it lined up correctly. So what we do is say, if you imagine that in between these two spaces, there's 9 little lines, each one of them would be worth a tenth. So I would say that right there is about 8.9 centimeters. Notice we always have a unit, so I can tell 8.9 of what I'm talking about. That 0.9, that's a guess. Okay, it might be, depending on how I lined it up, now it looks a little bit more like 0.8, okay, or maybe even 9.0. But the point is, on this scale, if you're going up by ones, then the place that you have to guess is the tenths. And so we'll write a little notation saying that this measurement could be off by a tenth of a centimeter. We're going to call that tenth of a centimeter sort of the buffer zone. We're going to call that the uncertainty. So in every measurement, there is both a measurement value, and then there's a unit, and there's a statement that says the place that we guessed is in this case, the tenth place. Now, if I measured the same object with a different ruler, for example, this ruler, I actually have little teeny lines that show me the tenths place. Well, to me, that looks like, and I'm not sure the camera will show it, that it's about halfway between that little line and the 9. So now I'm not guessing the 8.9. I know it's past 8.9 and less than 9.0. So what decimal place would I guess there? If I have the tenths place, then I have to imagine 10 little lines, which I can't draw, and say that's about 5 of the 10 little lines. So the 10 little lines would be worth a hundredth each. And I would say that measurement is 8.95 centimeters. And now that's the decimal place that I guessed. So this 9 I'm certain about now. This 8 I'm certain about. The 5 could have been a 4, it could have been a 6, depending on how you looked at it. So I'm going to say this could be off by 0.01 centimeters, and that's a different uncertainty because we had a different ruler. Every time you measure something in this class, you have to decide what decimal place will I be guessing. For example, if I wanted to measure my temperature, here's a thermometer. Let's see if we can see that number. Okay. Looks like it's about 30, but look at the lines. Looks like there's 1, 2, 3, 4, that the ones place is shown. So that measurement right there looks like it would be about 30, 31, 32, 33, almost 33, maybe right on 33. So what would I write if it was right on a line? At least it looked like it was on a line. Well, I would have written 33, okay, 0.0, because on that, and that would be degrees, because on that thermometer, if you have the ones place, which you can see here, it goes 30, 31, 32, 33, 30, up to 40. So those are the ones place. If I have the ones place, then I can guess the next decimal place down, which would be the tenths place. So this would have an uncertainty of plus or minus 0.1 degree. Every time you make a measurement in this class, you have to first decide what decimal place do I know and which decimal place will I guess. And at least for a while, we're going to actually write down the decimal place we guessed. You'd see that the bottom of the meniscus, which is what we're supposed to measure, looks like it's between some lines. Now, it's hard to see. I put a blackboard so you can kind of see some numbers. Let's first decide what decimal place we should be estimating on this graduated cylinder. Now, we can see that there's the 1, 2, 3, 4, 5. Those lines are there. In fact, there's 10 lines between the 5 and the 6. What would those lines be worth? Well, if the ones place is given, then the tenths of 1 would be the tenths place. So for sure on this graduated cylinder, I know the ones place and I know the tenths place. The rule is the last line that is given, which in this case is the tenths place, I have to try to decide what value it would be in between those lines. So between the lines, if I imagine 9 little spaces, or that looks like the bottom of the meniscus, and it's kind of hard to see, is about, let's see, 6.1. It's bigger than 6.1, but smaller than 6.2. So I'm going to guess that's about 6.18. And so I would write 6.18 milliliters, like we've been doing. And I would say the place that I guessed was that 8, which is plus or minus 0.01 milliliters. We're saying that that last digit could be off by that much. This graduated cylinder goes up to a maximum volume of 10. So we'll call this a 10 milliliter graduated cylinder. If I had a different graduated cylinder, for example, this one goes up to 100. Okay, so let's look and see how we would measure the water level in that. Now, once again with the camera it's hard to see, but let's see what numbers we have. So it looks like the big numbers are the tens place. We have little lines between the 40 and the 50, so those must be worth the ones place. So I know for sure the tens place and the ones place. What's our rule again? Well, if I know the ones place, I have to guess in between the lines. And I'm going to say that that's a little bit past, well, it's kind of hard to see with this camera, but I'll say 40, 45. I'm going to say it's not quite to the 46. So I'm going to say 45.9 milliliters. Now notice 45.9 milliliters. A little hard to write up here. You'll notice that what I had before was plus or minus 100th. But this graduated cylinder is going to be plus or minus 10th. Each individual device, you have to look and see what decimal place will I guess. This, we would say, the plus or minus a tenth, we would say the uncertainty is plus or minus 0.1 milliliters. That's the uncertainty. We're also going to learn that we would say that the tens place, the ones place, and the tenths place were all measured. Okay, so we'll count, even though we guessed on the 9, we're going to say that the 4, the 5, and the 9 were all measured decimal places. We will call that 3 measured decimal places, or 3 significant decimal places, or significant figures for short. If you had another graduated cylinder, maybe this one. So here's another example. This is a graduated cylinder that goes up to 1,000 milliliters. That we call it a 1 liter graduated cylinder. And you can see that the water is there between, or right near the 400. So let's see, using our rule, what's the smallest line worth? Well, let's see, that right there is 300. I don't know if you can see this very good, but there's 9 little spaces or 10 little lines up to the 400. So those must be the tens place. So it'd be 310, 320, 330, etc. So if we know the tens place, what's our rule? Well, then we should guess the ones place. So it's hard to tell. I think that meniscus is a little bit below the 400. So I'm going to say it's about 394 maybe. So I would say 394 milliliters. Let's see, and which decimal place did we guess? Well, we guessed the ones place because we knew the tens place, so we guessed the ones place, and we would say plus or minus 1 milliliter as our uncertainty. So the volume of the water in the graduated cylinder is about 394 milliliters plus or minus 1 milliliter. So the general rule is find out what the smallest line is worth in a decimal scale, and then you get to imagine 10 little spaces in between and get the next decimal place down. That's why when you were little, you learned the names of the decimal places, the hundreds, the thousands, the tens, the tenths, the hundredths, so that we could have a conversation about which decimal place is the one you're looking at. And here's your 3 homework problems. The little block of wood, pretend that's a little block of wood right there, and that's the ruler. I want you to measure the length of the block of wood, record it correctly, with the correct decimal places, units, and uncertainty. And there's the second block of wood and the third block of wood. Notice each ruler is different.